Hello guys, welcome once more to class online. My name is Tutor Dami, and in this edition of Jamb Physics 2014, question number 41 to number 45, we shall be dealing with an aspect of physics that has to do with transformer, and also an aspect of physics that has to do with radioactivity. Now, if you have quite some things to learn from this aspect of physics, because it's one of those aspects that some students find difficult to understand, but it is as simple as ABC, and we shall be breaking it down in this series very carefully. Now let's check. Don't forget that if you learn something from this video, click on the like button. We have more content to send to you that will better help you analyze and understand Jamb Physics. Let's go to the question number 41 now. The magnitude of the angle of dip at the equator is what? Now this question is under magnetism. Now, whenever you hear the word equator and angle of dip, it's very, very simple. Let's check it out now. Now, this one says what? The inclination from the horizontal plane, and then we have the zero inclination at the equator. So the angle of dip at the equator is simply 0 degree, and that is. But first of all, I would like to explain what I mean by angle of dip. You know, angle of dip is a very big question for many students. Now, it is actually the distance. Okay, the angle between what's it called? The angle between the true north and the magnetic north. Like you have in my picture here. This is the angle of dip, the dip angle. Okay, it is the angle between the true north. Now, what is true north? This direction I point to is the true north. But this is not the north of a magnet. This is the north of the world. This is the geographical north. But this is the magnetic north. Now, the angle between the geographical north and the magnetic north, this angle here in between, is called the angle of dip. And if someone asks you to define angle of dip, it's as simple as that. Just say it is the angle in between the true north and the geographical. The true north, that's the geographical north, and the magnetic north, and that's just it. Okay. Now, but angle of inclination is the angle between the horizontal and the magnetic north. Magnetic north and the horizontal. This is the horizontal line, and this is the magnetic north. The angle between the magnetic north and the horizontal is called the angle of inclination, and many students need to understand this these two words, angles, in magnetism, because many questions in theory usually ask for them. I've seen so many past questions asking for these two angles, and please, it has to be clear to you. The angle between the true north, the horizontal plane and the magnetic north is called the angle of inclination, while the angle between the true north and the magnetic north is called the angle of dip. But for when the angle of dip is at equator, that means it is closer to the what? It is at, that means the magnetic angle is at the same point with the true north. Then that means that there is no angle between them, because the two of them are now at the same point. And that means that the angle between them at the equator is 0, because the two angles, both magnetic north and the true north, are now at the same point, and they only get to the same point at the equator, and that is the answer. It is a 0 angle. Okay, now let's talk about the lesson transformer. The diagram above is that of a what? Now, there are two types of transformer: step up transformer, step down transformer, auto transformer. And those ones are just fake. They are just stupid things being said. They are just jargons. An auto transformer, there is nothing called auto transformer. Then an oil transformer, it is not among the types of transformer we were taught. So those two are just jargons. But the first two are types of transformer. We have step up transformer and step down transformer. Now what? Now, what kind of transformer is this? Now look at this one. This one is the primary winding, and this is the secondary winding. Now, but you can see the voltage here, the winding is smaller here, but it's step up here. So this transformer, the one coming in is smaller, but it's step it up, right? So this is a step up transformer. Why? Because the primary winding is smaller, but when it goes to the secondary, it's stepped up. That means that the voltage here, the more the winding, the more the voltage. So there's less voltage here, but there's more voltage here. So the voltage level step up. The voltage level step up. Now, it is step down if this one here, if there are more windings here, and less winding here is a step down transformer. So you can draw a step down transformer when the primary is more and the secondary is smaller. So it came from more to smaller, that's step down. But this one is from the primary input, it came from less to higher, and that is step up. It just stepped up. So it's a step up transformer, and that is the answer to the simple question. Let's talk about okay, I even use a diagram. Step up transformer as the primary, you can see the primary here is smaller, but it came higher in the secondary. And here the primary is more, step down, but the secondary is less. Can you see? So it went from up, big one, to small one, is step down. This one from small windings to big winding is step up. So this is step up transformer and this step down transformer. Now, and the answer is just step up transformer. Okay, and I told you also that the way it is like this, it means that the voltage will increase because the more the windings, the more the voltage. So the voltage here is less, but it will step up. And here there's more voltage, but it will step down. And as the voltage increase, the current fall. So here has more current, and here has less current. Here has less current, and here has more current. So that is the answer to that question. Number 43. The EMF, the electromotive force in the secondary winding is what? EMF is like voltage. EMF is voltage across the terminals of a cell. Now, EMF is voltage. That means EMF is the work done. So just like voltage, you know, I said before that the more the windings, the more the voltage. That means the more the turns, the more the voltage. And in this case, there's less turn, and here there's more. So that means the voltage went from low to high. So in this diagram, the EMF is increasing because it went from low to high. It became higher, and that means the answer to that question is simply increasing. So it is by the transformer formula that voltage and turns are the same. That means they are directly proportional. That means that the more the turns, the more the voltage. I've said that before. The more the turns, the more the voltage. And this thing you see here is the formula for transformer. V secondary over V primary. That means the secondary voltage over primary voltage equals secondary turns over primary turns. This is called the transformer formula. And this formula can answer any question on transformer in physics. Please take note of the formula. Let's go to number 44 now. Now, what type of reaction is represented by the equation? You can see that x2, this is x plus x, that's 2 producing 1 with energy. Now, when now this question is on radioactivity, sorry. Now, when two nuclei produce 1, and what will it be called? What kind of fusion is that? Is it fusion or fission, or chain or ionization? Now, actually, the answer is not chain. The answer is not ionization. The answer is between fusion and fission. Now, we've learned that fusion has to do with fusing. 2 fuse into 1. And in this question, x and x are fusing into 1. Now, actually, there should have been an x here. This is a typo. It should have been a single substance here. This is a typo. That means 2 and 2 match to produce a single one and neutron with energy. But the main thing produced here is just one of them. Answer for this question is just A, fission, because they are fusing to 1. 2 is fusing to form 1. But fission is the opposite of fusion. Fission is one breaking or disintegrating into smaller particles, and that is fission. But this question is just a typical example of fusion reaction because 2 is forming 1. 2 smaller nuclei are forming 1 giant nuclide, and that is the answer to number 44. The answer is just nuclear fusion. Like I have this drawing here. This is fusion. 2 deuterium and tritium, they are both hydrogen. They are forming helium, 1 helium. But fission is 1 radioactive object, okay, forming 2 or more. It broke down into this, and that's fission, and that's the answer. So the answer is fission. The last one, when an atom undergoes a beta decay, the atomic number of the nucleus what? Now, the word beta decay needs to be explained. Do you have any idea which of the options might be correct? When we say that something has a beta decay, what does it mean? Now, what it means is very, very simple. In radioactive nucleus that undergo beta emission or decay, has a neutron in its nucleus converted into a proton and an electron. Okay, then it ejects the electron with high kinetic energy. The remaining nucleus has one more proton and one fewer neutron. The atomic number increased by 1 and the mass number stays the same. An atom undergo a beta decay when the atomic number of the nucleus increase by 1. So you can see here now, I have hydrogen 3 1 and helium 3 2. One atomic number here is 1, but here it increased by 1. So whenever the atomic number or the proton number increased by 1, it is said to have undergone a beta decay, and that is the answer to that question. It is an increase in the atomic number by 1, and that is the meaning of beta decay. Don't forget, if you learn something from this series and if you want to get more content from us, click on the like button. We have lots of content to send to you that will better help you understand physics. Until we see you guys, take care of yourself and bye for now.